Hello, everyone. Welcome to today's webinar, Teaching Databases, Combining Databases Illuminated Hands-on Cloud Labs, hosted by Jones & Bartlett Learning. This webinar will be recorded and shared with all registrants after the presentation. We also have time allocated at the end for a Q&A, so please feel free to submit any questions in the chat, and we will try to get to all of them after the presentation. Let's meet our presenters. Today, we're joined by the three authors of Databases Illuminated, the 4th edition, including Catherine Ricardo, who is a professor emeritus of computer science at Iona University, Susan Urban, professor emeritus at Arizona State University, and Karen Davis, a professor at Miami University. We're also joined by Steve Webster, a solutions consultant at Jones & Bartlett Learning, who will give us an overview of Cloud Labs for Databases Illuminated. Let's get started. Catherine, over to you.
Okay, well, thank you very much, Mark, and welcome everybody. We're delighted that you're here today, and we know that you're really here to hear about the Cloud Labs, and I promise you that Karen and Steve will get to that. But in the meantime, Susan and I would like to talk to you a little bit about the book. So our first topic is, why was the book written? Well, we had several good reasons. First of all, we were excited to be able to incorporate the Cloud Labs. They're a great way for students to be engaged in the material and a simple way for instructors to incorporate the labs in their database classes. And we also wanted to catch up on some big changes to the database field, namely the shift from the relational model to various big data models, and more awareness of data privacy concerns now that we're in the world of big data. And there's also a better understanding that a data manager needs to be a responsible steward of data, so we wanted to incorporate that in the book. In the preface, we mapped the text to the ACM Computing Curricula 2020 standards, but as most of you know, there's a proposed new computer science curriculum, CS 2023, which is now in a beta version and waiting for everybody's comments. That curriculum has 18 knowledge areas, including data management, which is the one, of course, that we're concerned with. Our text covers all of the knowledge units in that area. And the curriculum also emphasizes ethical storage and use of data and professionalism, which is one of our major themes. Next slide, please. So our aim was to combine combine theory with practical knowledge. And we try to engage students as active participants using several techniques. First of all, we have code, lots of code for them to execute. We have accessible chapter exercises. We have the lab exercises, and we have student projects. Those projects have steps that go through all the phases of database design, creation, and use, in step with the chapters of the book. The intended audience is juniors and seniors who have some programming. Ideally, they should have data structures, but for those students who might need it, there's an online appendix on physical data organization that includes B+ trees. Next slide, please. The book presents a balanced coverage of practical and theoretical concepts throughout. The earlier chapters are appropriate for a beginning database course, and the later chapters for either an advanced undergraduate course or a graduate level course. We start with conceptual modeling early in the book, and we use the ER, EER, and OO models. And then in later chapters, we map them to the relational, object-oriented, and object-relational implementation models. We've divided the coverage of SQL into 2 chapters in this edition. We've put the fundamentals of data definition and data manipulation language in chapter 5, and advanced concepts we've moved to chapter 7. And there we include functions, temporal features, active databases, JDBC, and other advanced topics. The later chapters deal with more specialized or advanced topics, as you can see from the titles. Now, chapter 16 is a sort of a standalone chapter. It addresses social, ethical, and legal issues, and that's very much in line with the computing ethics requirements of CS 2023. We think it should always be included in any database course. It's independent of the other chapters. It can be covered at any time during the semester. It starts off with some realistic examples of ethical problems that your students could face and presents a framework for ethical decision-making. It has ethical standards for computing professionals from various organizations. It has the summary of privacy laws in various states and countries. And that's important because during their career, students may have to create databases that are in compliance with international laws, so they need to know about those laws. It also has intellectual property laws that could affect a data manager. Next slide, please. So here we show the format of a typical chapter. We've chosen chapter 5. On the top left, you see that we have a list of the contents by section number, and each of those sections has possibly several subsections in the actual text. Then we have a statement of the objectives, and we phrase that for students as things that students are going to learn in the chapter. Then, of course, we have the contents of the chapter itself, which we don't show here. And each chapter ends with a chapter summary. In the summary, we give a quick review of the chapter. We try to highlight important terms in boldface. And then we have exercises, and you're looking at the beginning of the exercises for chapter 5. In each of the chapters, we've tried to put in exercises that all students should be able to do easily, and then we go on to more challenging ones. So here, the first exercise refers back to a section of the chapter, and it uses the university example that runs throughout the book. Then the next several exercises use a different example. At the start, the students are asked to execute a script to create the database for this example, and they're told to use Oracle, MySQL, or any other relational database management system. The script is printed in the book, and you can also download it from the ebook or from the instructor materials. And then the students have to use that database to write and execute a set of about 20 SQL queries, and they're pretty much in the order of increasing difficulty. Then those are followed by some data dictionary queries that refer to the same example. And then there are 2 more challenging examples where students have to write their own DDL code, insert records, and then write queries. So you can see we tried to vary the difficulty of the exercises from easy to challenging. Okay, and now Susan will talk about resources and some key features of the book. Next slide, please.
Okay, thank you, Catherine. I know that when I was in a position of having to select a textbook for a course, I was very interested in the types of resources that were provided for instructors and for students. And we have a lot of those resources that I'll outline here. We do have downloadable code for most of the chapters. Anywhere that you find a figure that has code in it or a section of text with a significant portion of code, all of that code is available and executable by students and the instructor. Throughout the textbook, we provide a university example to reinforce the material as we're presenting different concepts, but online we also have a sample art gallery project with step-by-step instructions and solutions, and that's very useful also for reinforcing some of the material. We also have additional student projects. There are 6 different projects that are available. These are great semester-long projects that are useful for students to do. And again, we provide instructions for those as well as solutions. Along with this, we have a very useful instructor's guide. And what you see on the right-hand side of the page here is an example of the first page of the instructor's guide from chapter 4 on relational database management and SQL. We, of course, reiterate the learning objectives for those chapters, as well as issues related to the student projects and how those can be used in the chapter. A very important section of the instructor guide are the teaching suggestions, where we go through and describe what you want to think about when you're teaching that chapter. Most of this has been put together based on our own experience with teaching this material. So we outline things that you want to think about. We cover some of the things that we found as difficult issues for students to deal with, as well as ways to deal with those issues when they arise. And then new in the instructor guide, we also have learning outcomes for the virtual labs that we will talk about in a few minutes. Next slide, please. We also provide very useful slides for every chapter. That's a big time saver for most instructors. You'll see here on the left-hand side of the page an example of some of the slides from the SQL chapter. All of the chapters, at the end of each chapter, Catherine outlined some examples of the exercises. We provide solutions to all of those exercises to make it easier for you in the teaching process. We also have a very extensive test bank with a huge collection of true, false, multiple choice, and fill-in-the-blank questions. And all of those are LMS ready. They are ready to be plugged into whatever learning management system you are using. In addition, for the resources, we have an appendix that we've now put online instead of actually in the book. The appendix contains materials that we've extracted from previous editions of the book based on the topics that you see listed here: physical database, higher normal forms, things in greater than voice code normal form, relational algebra operators such as division and outer join, and of course for historical purposes, the network and hierarchical models. Next slide, please. So I'll quickly outline a few key features and updates. Catherine has already mentioned that we provide extensive coverage of social, ethical, and legal issues, which is a very important aspect of the book. And we are particularly proud of the new material that we have there describing ethical dilemmas that students may face, as well as a framework for ethical decision making. And then along with that, we address privacy issues throughout the text, including the issue of data de-identification. With respect to security, we now provide more coverage of SQL injection, and in particular, we cover specific code for mitigation of SQL injection. What you see here on the right side of the slide is an example, one of the figures that addresses the use of parameterized queries in JDBC for the mitigation of SQL injection. And all of that, again, is available to download and execute for your students. Throughout the book, we also, where appropriate, when we're covering certain topics, we also address the relevant security issues that might apply. Next slide, please. Some additional key features. Databases Illuminated has always addressed forward engineering, mapping from conceptual to relational databases, but now in the text, we also address reverse engineering as well, for the cases where a student might run across a relational database that is not very well documented. And we provide some very nice tables using graphics that show and explain the forward and reverse engineering process. We, of course, still use Oracle to illustrate relational and object relational database concepts. And we also use InterSystems Iris to illustrate object-oriented database concepts. What you see on the left-hand side of this screen is a figure that shows the information that we cover about the InterSystems Iris data platform and all of its different components. And then we primarily focus on the use of objects and then how to use Iris Studio to create object-oriented schemas from a UML diagram. In the big data chapter, we've also expanded a lot on NoSQL databases. And in particular, we address the use of MongoDB for document-oriented databases and Neo4j for graphics-oriented databases, for graph-based databases. And Karen Davis is going to talk to you about that in a little bit more detail in a few minutes. Next slide, please. Also new to the 4th edition, we have of course updated SQL wherever it appears to the latest version of the standard. With respect to semi-structured data, we have much more coverage of XQuery for XML with some exercises that use tools such as Notepad++ and BaseX for actually creating XML and executing queries. New to the chapter is that we provide coverage of JSON also as a form of semi-structured data, together with comparisons of JSON and XML so that students can understand when you might want to use one tool over the other. And then, of course, with all of these changes, we have updated Oracle to address these issues. For example, in Oracle, you'll now find examples of using SQL to query JSON data, create and query JSON data, to create and query XML data. And then we have also added more information about SQL analytic functions in private temporary tables. In the distributed databases chapter, we now cover blockchain technology so that students can learn about decentralized peer-to-peer networks and also understand the role that cryptography and distributed ledgers play in creating blockchain technology. What you see on the right-hand side of the slide here are just some examples of the figures, some of the figures that appear where we explain blockchain architecture as well as nodes in a blockchain network. In the data warehouse chapter, we have also expanded on data analytics, and we have a new section on the topic of data lakes so that students can learn about large collections of raw data as a form of data warehousing. So the last bullet here is the bullet, I guess, the update to the book that we are the most excited about, and basically the topic of this webinar, and that is the new accompanying virtual labs, where students can get hands-on access to tools that can be used to reinforce the material and the book. And so Karen Davis has been the designer and implementer of the virtual lab. So at this point, I'm going to turn it over to Karen Davis and let her explain the labs to you.
There are 10 labs that showcase practical applications of concepts from the book, and we'll go into more detail in the next slides. The foundational labs cover database design as well as introduce the relational model. So labs 1 and 2 introduce DIA, which is a drawing tool that includes relational or entity relationship semantics, so that students can select a concept and then the DIA renders it on the screen using the correct construct. And then we use Relax for executing relational algebra queries. Relax allows students to express queries symbolically, and then they can be executed. They'll see the relational algebra query tree. They can also type in some SQL and get the corresponding relational algebra for that. Next slide, please. Labs 5 through 8 leverage MySQL Workbench. So in 5 and 6, the students can execute the DDL that's provided in the text to create the university schema, and they can run all the examples from the chapter, they can do the homework, and then there are additional challenge exercises that use a larger data set. So Labs 7 and 8 allow students to create a data warehouse, and they'll express star schemas using DIA, and then they can populate it from relational sources and execute OLAP queries over star schemas. Next slide, please. The final 2 labs use NoSQL databases. Students learn how to create aggregation pipelines in MongoDB Compass, and then they learn to execute Cypher queries in the Neo4j environment. Both of these labs use the example database from the chapter and additional larger realistic data sets that allow students to do challenge exercises. Next slide. We're going to do a deep dive into an example lab. So what you're seeing here is that there's a connection between the material and the textbook. So we introduce concepts that the students can actually implement in the labs. So we have DDL constructs, and we have a sample schema, and then the students can build that and execute it. And then the challenge part uses a larger database with 15 tables and more complex queries. Next slide, please. And this is Steve. Steve is going to show us the lab.
Thank you, Karen. Appreciate it very much. Glad to be able to show you our labs. Hoping that get the right screen is showing at this point.
It is.
That should be the right one. Super. So what we are looking at right here is the virtual environment that is what we use to deliver our labs through the platform. The gray box is a virtual machine. On the left is a lab guide that tells us what we're doing and how we're doing it, with a menu bar across the top. At the beginning of the labs, we provide a pretty good introduction to what's going on and does a good scene setting. We build our labs so they can operate either in conjunction with the book or independently of that. So you can you and your students can purchase the labs to work with the book or apart if you should so choose. In that introduction is a really key, great last paragraph. In this lab, you will assume the role of a database professional, ... and I'll let you read that on screen. All of our labs are built to provide real-world circumstances and have the students use real-world tools and real-world exercises. In the introduction, we have a lab overview, followed by a set of learning objectives for each lab. Each topology is delivered to the student in on-demand form. All they need is a browser and an internet connection. Each lab, the topology will differ lab to lab, as will the tools and software that are being used. All of our tools and software are fully functional software. It's the same stuff that students and workers would use when they get out into the big bad world. The key deliverable for our labs at the end of the whole process is a lab report that the student builds out as they work their way on through the labs. JBL takes care of building out that lab report, and you can see from the progress bar across the top that I'm 42% of the way through this lab. So let's dig on into the lab, and I will show you how we build things out. At the beginning of the lab, we use a lot of screenshots, a lot of red boxes to make sure that students don't get out of bounds. So at the beginning, it's on the workstation desktop, double-click the MySQL desktop icon. And I'm not going to bother going through each of these steps for you, but you can see how that all would work. And you click on the student and enter the password, et cetera, et cetera. I'm not going to go through all of these steps. That would be pretty boring for you, but you can see how we make sure that the student gets going where they need to go and provide all the context that the student needs to do the work. As the student goes through the work, they will end up coming to a step. I'm going to fast forward through a whole bunch of work. So step 18, which is make a screen capture showing the following, ... You can see that that step is not complete because it is red. All the student needs to do, presuming they've done the prior 17 steps, is to click on that camera icon. And that takes a screenshot of the virtual machine and automatically updates their lab report and drops it into the lab report that we assemble for them. The student can review the screenshot by clicking on that camera, and here is that screenshot. The screenshot is really quite important because we do a watermark whenever we do one of our screenshots. We drop in the name of the lab, the virtual machine that's being used, date and timestamp, and the student's name. And that happens every time automatically. This builds into the whole process the academic integrity that we know that instructors really require. So we're going to close that. The student is able to add an optional comment if they so choose, and then they save that, and that gets dropped into their lab report. If the student doesn't like the screenshot for whatever reason, they're able to delete the screenshot. You'll notice that the lab guide progress goes backwards, and then the task turns red, indicating that it is incomplete. So I'm just going to take that screenshot again. So as the student makes their way on through the labs, we gradually change the language. Instead of providing a whole bunch of click here, click here, click here, we are going to change the language a little bit and ask the student to lose some of the training wheels. And we start using words like type and execute and configure. And we have the student work through the various data demands that are part of the lab. All the student has to do is take the appropriate screenshots as they go through the work. The student needs to only worry about doing the work. They don't need to worry about network configuration and installing anything on their computer. And that also means that instructors don't have to worry about that. Everything is ready for the student. All they have to do is click and go. Our challenge and analysis sections, as Karen is pointing out, we have a real world situation. So here is that situation. where we're asking the student to do various pieces of work as a database professional. And they're going to be doing SQL query writing. The next challenge task is, again, spinning out from scenario 1 and asking the student to do further work. Each of our labs takes about 3 hours to do. We allow the student to disconnect from a lab and save their virtual machine so they can come back and pick up where they left off after dinner or the next day or whenever that may be. We do provide tech support with our labs. That tech support is a 24/7, 365 support, tier 1 support. We make sure the labs are up and running and available for the students. By using virtual machines, we also allow the students to reset their own lab. Not surprisingly, students sometimes can get themselves in hot water and mess things up a bit. Sometimes the best thing for them to do is to reset the lab to factory specifications, and then they can start all over again. And the beauty of that is that we allow the student to do that for themselves, and the instructor doesn't need to be involved in that at all. So I'm going to leave the lab for a moment and create a new state save for myself to show you some of the pieces that you're going to see as an instructor and how the student can output their lab report. So we've just exited the lab, and the lab report here is sitting there. Click there, and you see all the screenshots dropped into place, and the screenshots that don't exist are also, you can see where they are supposed to have gone. Obviously, I'm not going to be doing anything with this until I'm all done with all the work. But when I get done with everything, I'm going to click on this PDF icon, and I'm going to download that lab report as a PDF. That's the document that I, as a student, would deliver to Karen, who was my instructor. We usually have the instructors build an assignment within their LMS for the students to drop in their PDFs. And this is what that PDF looks like. This is a sample lab report, which is the answer key that we provide for instructors. We provide a header with the student name, student's email address, their progress, and then every screen that they dropped into their lab report gets output automatically. So you know that page 1 will have those screenshots. Page 2 will have steps 7 and 14, and the instructor can use that as an answer key for easy grading in a side-by-side fashion. We also provide for the instructor a 5 or 10 question lab assessment quiz for each lab. Those are ready to be imported into your LMS, and those will do auto grading for you. The last few things I want to point out are some of the analytics that we give you. Click on students, and you can see all the students that are in your class. You can drill in to a student by clicking on their name. You can see their progress through the various labs that they're working on. Click on a lab, and you can see every session start and every session end, so that there is a tremendously good audit trail here, so you can see exactly what your students have been doing. We give you further analytics at the classroom level by clicking on analytics. We give you 3 different measures: time on task, lab progress, and completed sections. So pick a measurement, lab progress, for example, a lab, and you can see the bar graph that makes up the various students in this particular lab and their current status. Click on a group, and you can see what students make up that group. If this lab was due next week, we might want to reach out to Jordan and Taylor and remind them that their lab is due next week and they probably have some work to be done. You can also click over here and see that Feluke is just about done, and we probably don't need to worry about her. We also provide all of that information about lab sessions as a CSV that you can open in Excel. You can output that using standard time periods as well as a custom window of time. So I think that's a pretty good tour, a quick tour of the labs. One more thing I want to show you, we do have a tutorial. We have also produced videos that instructors and students can use and access to get them up to speed on how the labs work and how to make their way through the user interface. Mark, do we have any questions?
Yeah, thank you, Steve. We have a bunch of questions coming in right now. Most of them focused on the actual text, the textbook. Catherine, I'll start with you. One of the questions that came in from Rob was, why do you use Oracle for the book and MySQL for the labs?
Okay, well, first of all, I want to mention that Oracle and MySQL are number 1 and 2 in popularity in the world as database management systems. So we think it's a pretty good idea for our students to have experience with both of them. I've always chosen to use Oracle because Oracle allows you to do almost everything you want to do, including object relational database management systems. So it has all the features that you could ever want. MySQL is a little bit more user-friendly, and Karen actually would be a better choice to answer questions about MySQL.
It's a lot more streamlined. It has a smaller footprint than Oracle, and it also has a community edition that people use in industry. So it's very robust for practical use, and it has also a user community that you can get questions answered and so on. So I like to use it in my classes, and I think it's fine for the foundational material. I've used it in 4 labs here in the cloud labs. And if you wanted to do more in-depth things, if you wanted to use object relational features, you would want to move to Oracle. And Oracle also allows a free download. So that's not part of the virtual labs, but it is certainly something you can use with your students. And there is a lot of tested code that you can use that we supply, so that's available for you to use if you're not just on your own if you want to use Oracle. I just happen to choose it for the labs.
Great, thank you both. This next question I'm going to send over to Susan. Susan, why do you use both ER and UML diagrams for conceptual models?
Susan.
Audio.
Thought I had done that. So EER diagrams, that's, I guess, the gold standard in conceptual modeling was introduced years ago. And we've always followed that. There are a lot of different notations that are out there. So from a teaching perspective, it's a great way to start with covering EER diagrams. UML developed more from an object-oriented point of view. It follows a lot of the same concepts. And so eventually, after we introduce the EER model to get students used to understanding conceptual modeling and the different concepts, we then kind of graduate to using UML because it introduces object-oriented concepts where you can also identify attributes, you can identify procedures, and it fits very well into mapping more to the object-oriented data world. And then I think it's wise, we think it's wise for students to know both diagrams. They're more than likely going to go out into the world and run across both notations. They all have similar concepts, but they're used for different things, and students should be aware of both of those. So that's why we cover those.
Thanks, Susan. This next question, it comes from Dave. Dave asked, how do you handle correcting so many submitted assignments? Karen, I'll start with you.
So, well, they're in a uniform structure when they come out of the labs. And so it's fairly easy to get into a rhythm doing the grading. If you use the multiple choice questions that we provide that are LMS ready, those are auto graded. So that's a bonus. You can do that for checking students' understanding, for getting them to prepare before class. You can assign those quizzes. So there are modern ways to help with grading.
I'd also like to mention that for the student projects, it's a really good idea to have those projects done as teams. So instead of correcting for each individual student, you're correcting for whatever number of teams you're going to have. And working on a team is a very good experience for students and allows them to build a portfolio to show that they're able to work cooperatively with others and to keep track of their contributions.
Thank you both. Catherine, that's a great segue. Oh, I'm hearing some feedback. Sorry about that. That's a great segue into our next question. Any ideas for projects that students can do other than the ones that are in the instructor's resources?
Well, I found that very often students are able to come up with their own projects. Often, if they are working in a volunteer organization or a community organization, those organizations often need somebody to come and organize their data for them. So often they can create a database that's going to be useful for some community organization. Another source would be other departments within the university. It's possible to work with other professors who have needs. And another idea is that if you have a capstone course, which is a software engineering course very often you can sync the database course with the software engineering course and have the software engineering students do a front end for your database. So that's another thing that you can do. The only problem is that it's important to manage expectations for your clients, because the organizations that you're working with, the departments that you're working with, can't expect that student is going to stay around and provide tech support after they graduate.
Yeah. I'll add that I have always used group projects, and students have never had trouble coming up with topics. They're very good at being creative, coming up with ideas. And as Catherine mentioned, I usually had to kind of scale them down because they would they would start with a huge idea and we would have to scale it down for doability during the semester. And then I'll also add the 5 projects that we also already have in the book. Those address, there's a community project, there's a theater project, there's one on a car dealership, a photo studio, and then also a wellness clinic. And again, all of those are laid out. They kind of map to the different topics that we cover as we go along different chapters in the book. And we provide complete solutions for those as well.
I've also incorporated in my classes, when I work with a capstone team doing a database design project, I'll take their requirements and use that as a project idea in future courses. And I can say, here's something that students developed and they wrote the requirements, and now it's your job to create the database for it.
Thank you all. And listener commented that they use the wellness clinic as a lot of their students work in healthcare.
Oh, good.
Yeah. Oh, yeah.
I have a couple questions here too around recordings. Yes, we will be sharing this recording after the presentation. We'll probably send that out at the end of next week. I know that we've got a few more minutes here. And I have a couple more questions. I'll keep this one up for Catherine. Is the SQL that you use standard?
Actually, we use a dialect of standard SQL. Very few products have implemented all of standard SQL, and most of them have made modifications and subtractions and additions to the standard. So the textbook itself has the Oracle version of SQL, and the labs have the MySQL version of SQL.
Great, thank you. Here's another somewhat of a technical question here. Why don't you do formal normalization using Armstrong's axioms? Catherine, I'll start with you and let everyone else chime in.
Okay, well, first I want to mention that we actually have that approach in an appendix. And the reason that we put it in the appendix is that we found that not all instructors want to do the formal approach, but everybody needs to do the normalization by example approach. So it's possible to use the textbook to do the example approach that goes through Boyce Codd normal form, and it mentions the higher normal forms. But if you are interested in doing the more formal approach, you can use the appendix.
Great, thanks. Steve, I have a question for you. Is there a way for instructors to create their own exercises in the Cloud Lab environment?
So the lab environment is a fully functional environment. You are certainly welcome to use the environment that we provide for you to do whatever you want your students to do. Everything is there, have at it. We do recommend that you, if you're using the lab to do the work in the lab, you may want to have the students do the work within the JBL space that we're expecting them to do for completing the lab before they go and do work in your classroom. But the environment is there for you. Use it as you see fit.
Thank you, Steve. I have a couple people asking about review copies. Yes, we can definitely send you over review copies. Any instructors are eligible for free review copies, and we'll be in touch with you after the webinar.
We're happy to comp review copies and lab access to instructors. You want to reach out to your sales rep and make that request through those channels.
Excellent. We just had another question come in here. I use Databases 2 currently. Each student has their own database and populates it use it for the semester. Do you have exercises that use some functions like sum, max, etc.? Karen, I'll start with you.
We have aggregation functions in the labs. So they write group by and having queries using and use those aggregation functions. And there are also some exercises where they write aggregation functions over whole tables. So they will definitely get practice doing that. And I would call those queries in the data warehousing labs OLAP queries, because they tend to use aggregation functions. So they have more practice doing that once they've built their data warehouse.
Excellent, thank you. Another question here, someone's looking for a more kind of in-depth look at the lab environment. We're happy to set up specific demos for anyone who's interested. I'll follow up with those. Anyone who's interested, and Steve and our local rep would be happy to walk you through any of the specific labs that you may be interested in. Steve, question for you. Are the labs LTI capable?
Yes, they are. We work with all of the 4 major LMSs, Moodle, D2L, Canvas, and Blackboard. We are using LTI 1.1, though we are adding 1.3 support later this year. It's a fairly easy and convenient way an elegant way of delivering the content directly through your LMS.
Excellent. Thank you all so much. We're at the core of the hour here. Catherine, Karen, Susan, Steve, thank you all so much for presenting, and thank you to everyone who listened in and submitted some questions. If you have any questions, don't hesitate to reach out. I'll get this recording over to you, but again, thank you all for taking the time to listen into this webinar, and I hope you all have a fantastic day. Thank you.